Hello, everyone. I'm Susan Nash, AAPG. I'm here in the office now. You can see my background. It's not actually a Zoom screen. It's my actual wall. At any rate, I'm thrilled to be here and so excited about this topic. We are so lucky to have Galen Huling and Thomas Smith here, who've been working in the Smackover and also in brine mining, both on the geological side and also on the processing side. And it's just so exciting to see the possibilities of getting into critical minerals, especially since we can use the knowledge we have of old reservoirs, et cetera, so we can bring together the two different sort of phases of knowledge and also bringing together and updating new technologies. And I'm happy to be able to say that this is sponsored by the Energy Minerals Division. So if you have not joined the Energy Minerals Division, please do. And also like to encourage you to be sure to renew your membership of the AAPG. And also I'd like to encourage you to join the Division of Environmental Geosciences, which is also co-sponsoring this event. So we will start with Galen Huling, who will talk to us a bit about the Smackover and the lithium, and then we'll have Thomas Smith will talk to us about the processes. So Galen is a geologist, Tom is an engineer. It's a great balance. So we'll start with Galen. So welcome.
Thanks, Susan. 1 second. Let me share my screen here.
Perfect. And you might want to put it on.
Yeah.
There we go. Good. Great.
No. All right.
That's good.
So, as was mentioned, my name is Galen Huling. I'm a geologist. I've been in the oil and gas industry since about 2008. I live here in Houston right now, North Houston and Spring. I grew up in Northern Virginia, just south of Washington, D.C., in a town called Woodbridge. Currently got a wife and my 2 boys. They're 11 and 13. They keep me busy, active. I did my undergraduate at Brigham Young University and my master's at TCU. While I was at TCU, I was picked up by XTO Energy, which had recently been bought by ExxonMobil. Then Exxon moved us all to Houston in 2018. Soon after I got interested in lithium, we came across some elevated lithium in one of the wells I was testing. And it got me wondering, where else are we just drilling past this and not even knowing it's there? What are we missing? An additional revenue stream that we could be taking advantage of. And so I started researching just lithium in general, where it's mined, how it's produced, and I came across a company called Standard Lithium. Now I had a good amount of experience in East Texas, North Louisiana, Arkansas already from my time at XTO. And so at the time I thought, if ever I was to be out of oil and gas, that might be someone I would contact or look to. And so come end of 2020, COVID, and all the mass layoffs in the oil and gas industry, got let go from Exxon. But that was my opportunity. I contacted Standard Lithium and said, hey, I know you're doing this pilot program in the Smackover. I have some experience in it. And if your pilot program is successful, you're probably going to want to expand. And so the timing was just right for me. They had decided a couple of days prior to that they wanted to bring someone on to do that work. So me and a couple other geologists did some regional mapping for them, and that got me started in the lithium space. After that, I did a feasibility for an investment fund. And currently I'm working with Blackstone Minerals. They have large acreage positions all over Arkansas, Texas, Mississippi, Alabama, within the Smackover and elsewhere. And so I'm evaluating their leasehold for lithium resources. I also recently started my independent consulting company, Grounded Energy. You can find it at groundedenergy.net, not .com, but .net. .com takes you to a different type of company. Anyway, so enough of my background. That's how I got started in it. So what I'm going to be going into in this presentation is, first of all, why are we even talking about lithium? Why is it important? Why is it a big buzzword? What are the market conditions? And then known domestic brine deposits. I'll go into general Smackover geology, formation trends, and then, the bottom line, because we're not just here to do science, but it impacts us financially. And so what's the monetary value and market access that is unique to the Smackover? So lithium is commonly used in things like glass and ceramics. But the main driver and reason for the increase in demand is from electric vehicles or hybrid batteries and portable electronics, iPhones, computers. But the main driver is the electric vehicle batteries. I got this chart here showing all the critical minerals needed for different clean energy technologies. And EVs and battery storage, that's the primary one for lithium. That's some of the other technologies and energy providers use it to a small degree, but the EV batteries is the primary driver. So in September of 2022, California banned the sale of new gas-powered cars by 2035. Followed soon thereafter by Washington, Massachusetts, and I expect others to follow as well. So that's just going to continue to increase the demand domestically for electric vehicles. And just this year, the EU did the same thing. So there was really a quite dramatic increase in the price for lithium because the supply hadn't caught up with that demand yet. And so it took, so that price increase really started in end of 2021. I've got this spot price graph here. Where's the, here's a spot price graph showing the last about 5 years of lithium price. Back in 2018, 2019, 2020, the prices were generally around $15,000 per metric ton. Then by the end of 2021, it was up around $70,000 per metric ton. Then there's the quite dramatic drop back down to what it's currently at is around $32,000 per metric ton, which historically is quite high, but not what China has set the price floor at. So earlier this year, in response to that dramatic price drop, China set their price floor at what was it, 36,500 was their sort of price floor. Along with that, there's U.S. strategy. So the Biden administration allocated $2.8 billion to build and expand facilities to extract and process lithium, graphite, or other battery materials. The DOE included lithium on its list of critical minerals, and the domestic production of lithium provides security for the domestic supply chains if, God forbid, something breaks down like COVID, or other, there are all sorts of geopolitical scenarios where you could envision us needing our own supply of lithium and critical minerals. And so in response to that, the Biden administration has put incentives in place to encourage that type of development. In response to that, over 12 new battery manufacturing plants are to be built in the U.S. alone within the next few years. You can see in this chart here, you can see where most of the lithium and rare earths come from in the world. A lot of the lithium comes out of Australia, Chile, and China, the raw materials, but over half of it is processed in China. And then the rest of it is Chile and Argentina. So domestically, here's the USGS produced waters database samples of lithium, and I labeled here the various formations. You got quite a bit in the Appalachian and Williston basins, and then what we're going to be talking about more is the Smackover here. I have highlighted in the red dashed lines the Smackover trend, but it's not the only brine out there. I think there are other basins that it may be able to be found in, but I think the Smackover has unique potential that I'll get into in a little bit. And this isn't a complete exhaustive list of all the lithium potential within the US. This is just a general map of the USGS produced water database. There are other data sources where you could add data points to this that show even more high lithium concentrations within the Smackover. So now we'll focus in on Arkansas, since that's where a lot of the concentration, a lot of the focus has been put within the Smackover. It contains concentrations on par or higher than a lot of the other highly sought after domestic brines. There's the Salton Sea, which gets a lot of noise about it. It's generally on average 211 milligrams per liter, and milligrams per liter is the same as parts per million, if you're not familiar with it. Clayton Valley, Nevada, where the primary producer of lithium in the U.S. is between 150 and 320 milligrams per liter. And so if you look over here to the map, you can see, on average in Union County, it's around 150. Columbia County, you have large areas over 300 parts per million. Lafayette has large areas, probably in the 400 parts per million. And then recently, I think it was February or so, Standard Lithium announced they drilled a well in East Texas, just across the Arkansas border, that has 600 parts per million. So as far as concentrations go, it's as high as anything else we have in the U.S., if not higher. So it's really exciting to see the numbers it's putting out. And while this is focused on Arkansas, these numbers are found into Texas, Mississippi, Alabama. So to me, it's a no-brainer that this is going to be something worth developing. So we know it's there, but how does lithium get there in the first place? Generally, a lot of the current production in the world comes out of either spodumene deposits or salar deposits. So the spodumene being, hard rock, granitic deposits that you can just mine from the surface. A lot of that is in Australia, Africa, some in China, and then the salar brine deposits are mostly, there's some in China as well, but that's mostly Chile, Argentina, Bolivia, and then a little bit out of Nevada. But usually the way it gets there is either the basement volcanics that I just mentioned, or volcanic ash, or the erosion largely of those volcanic deposits, and then concentrating that through evaporation in the salar deposits. And that's the way my theory on how the lithium in the Smackover got to be there is largely from the Luan salt below it. Sorry, go back one more. So early on in the Gulf of Mexico, it wasn't always an ocean. It was largely a salar. You had really shallow waters coming in, really high evaporation deposits that were then covered up by the Smackover. And with the continued spreading and faulting of the Gulf of Mexico, you had more and more deposits piling on top of that. This is a upper Jurassic time period, but the Smackover spans, almost the entire Gulf of Mexico. The primary reservoir within the Smackover is the Reynolds member. It's largely beach or shallow marine. It's composed of ooids and non-skeletal carbonates. Generally, reservoir porosities are between 10 and 13% on average. You can find higher, up to 20, 25%, but on average in that Reynolds member, if you're going to have a reservoir, it's in the 10 to 13% range. The thickness ranges from 150 to 200 feet thick, and the total depth is between 600 and 11,000 feet to the south. Shallow in the north, deeper in the south. So Moore and Druckmann had a good analysis of the Smackover and the diagenetic process it has gone through, and split it into three zones: a northern, a transitional zone, and a southern zone. So basically, like I said, you had the deposition of the Luan salt, then you had a regional unconformity, and then with the rise of relative sea level, you had the ocean coming in and Smackover deposits being put down. Then on top of that, you had the Buckner anhydrite, which for a lot of the oil and gas fields acts as a migration seal. That's one of your traps. It also works that way for lithium. To be able to concentrate those liquids, it needs to be able to be contained, just like an oil and gas situation. But unlike oil and gas, it's not going to just continue migrating up dip. I like to think of these lithium deposits as sort of the photo negative of an oil and gas play. Where we would see a water wet well being called a dry hole in the past. Now it's not dry. We're looking for the water. and there's a lot of dry holes out there, unfortunately, or fortunately. So there's a lot of data to go off of. But so after the Buckner was deposited, you had continual burial compaction, and then along those, from the faulting and also through the lower Smackover itself, you had a mixing of Luann waters with the Smackover waters, and that continued all throughout, as you had hydrocarbon generation, introduction of H2S into the system. And so I've heard, some people ask, is H2S associated with lithium? I've been asked that a couple of times. My general feeling is that no, it's not. The two don't coincide. They just happen to be have occurred in the same place. We could have had the mixing of Luann waters with the Smackover waters without necessarily having H2S introduced into the system, but we also had hydrocarbon generation and H2S generation, which happened to flow into the same system. But I could be wrong. Yeah, we'll see. So again, what does all this mean for the pocket? How does this impact companies trying to get into the Smackover? So I just did a very general, hypothetical situation based off those numbers I was describing. A reservoir thickness of say 100 feet. A standard section is 640 acres with an average porosity of 11% and a lithium concentration of 250 milligrams per liter, and a dollars per ton lithium carbonate calculation, and that came out to 492 million per section. So that's, if you're asking why all the hubbub, why all the focus on the Smackover, that's why. There's significant money to be made in the Smackover, and significant resources to power all those electric vehicles that are going to be made. It also has a unique place regionally within the US. So this map here I have shows the planned battery plant capacity in North America by 2030, also as well as the vehicle assembly locations that are going to be using those manufactured batteries. So you can just see that it has easy access to those southern battery manufacturing plants, or if you want, you can start shipping it all over the world. We have Houston, we have Louisiana, all sorts of places that you can have easy access to being produced from the Smackover. And a lot of that is due to the significant infrastructure that already exists due to the oil and gas industry. All the roads, railroads, electricity, pipelines. So I think the Smackover is in a very unique and poised to be a great lithium producer for decades to come. So that's all I have for my presentation. Happy to answer any questions or go back at some slides if you need to.
Well, thank you, Galen. That was great. I think what we'll do is we'll go ahead and save all the questions to the end, and then so we'll let Tom go. And then if you have questions, please put them in the Q&A. So you might stop sharing, and then we'll have Tom.
Okay.
And that was great. So thank you, Galen. You're welcome, Tom.
Okay, how's that, Susan?
Good. I can hear you and I see your screen. That's great. You want to speak again?
Yeah.
I'm saying there's no audio. Okay, you might need to speak up. I think some people are having a hard time.
Okay, good morning, everybody. Hopefully you can hear me. I'm coming in from Denver, home of the Denver Nuggets. Big game tonight. NBA Finals for the first time in 60 some years. So a lot of excitement in town. And it has a mining theme, the Denver Nuggets. So here we go. So we're going to talk about mining brines. And this is a presentation I've given in different versions to AAPG and SBE, SEG over the last year or so. I'm going to fine tune this a little bit more toward lithium, or quite a bit more toward lithium extraction today versus what I've shown in the past. And so, let's see, what can we forward here? Here we go. So, how do we explore for mineral rich brines? Well, the company I'm with now, and just back up a little bit, I've retired for about 5 years from Whiting Petroleum. I did about 40 years in oil and gas. And during that time period, I've always dealt with water and produced water with oil and gas production. You really, when you start thinking about it, you're producing more water than you are oil. But because it never had a revenue associated with it, it always had an operating cost associated with it. We kind of looked at it as kind of the redheaded stepchild. You know, anyone who drills a water well or dry a hole, that's not a good thing. And so it's just getting a new mindset, and it's trying to figure out, you know, how we can, you know, start a new revenue stream, and how can we pivot, and how can we change our thinking that we've all been brought up with in oil and gas, especially some of this older guys like me, and and how do we you know, look at what's in front of us and what the opportunities are with our skill set. And that has to do with engineering, geology, geophysics, you know, the whole technology realm. And a lot of this stuff we're going to be talking about is kind of new to both of you know, both geologists and engineers, and that's more mineral processing and chemical. It's really a matter of you know, chemistry in mineral processing. And so the company I'm with now, Brines International, it's a small company. It basically has some technology associated with it, some patents. But really what we're trying to do is develop scalable mineral extraction technologies that kind of promote, you know, domestic production of rare and critical minerals from brines and industrial waste sites. So mining, runoff, collection ponds, those kind of things. But really, in my world, it's oil and gas production. So it's the water associated with that. And the ways to do that for small companies, you got to kind of work with the DOE, ARPA-E, and some of these, and that's tough being small, but you got to partner up with some larger companies that are better suited for getting these grants from the DOE. But in the end of the day, we can help this industry partner, whoever that may be, and meet some of their net zero carbon carbon goals and our ESG strategies. So our kind of mantra is, and our trademark saying is, we have a solution: mine the brine. So how can geoscientists transition? You know, kind of some of the things we used to do is we used to think that oil and gas was the only thing, the value we'd get from drilling. If you didn't hit oil and gas, you know, you just cost the company some money, and you got to plug it out. Another thing we kind of used to think, well, how do we generate a prospect? You know, it's different from what others have done.
Well, have you looked at Facebook?
Okay, we'll wait for operators to prove up a new resource place concept and then kind of act, you know, kind of do the corner shoot thing. You know, so how do we kind of think outside of the barrel, you know, and do these, you know, and do we move to a new job, when we get laid off, kind of like what Galen was talking about. I mean, that's just a perfect example of how we pivot into something we've kind of dealt with, but now is not important to us. It is important to us. Now it's the brine. And so we can take this calcium carbonate that we can actually extract out of brine using CO2. That's one of our technologies, and we can use it and send it into, high-end specialty minerals markets worldwide. Now, the new thing here we're talking about today is lithium carbonate for EV battery manufacturing, and Galen talked about that. We can start looking, within if we're working for a major, working for, an operator, look at the well data from all your boreholes, and that includes the dry holes, the quote dry holes. Those are the best ones, really, because now you've got, you've got a resource. It's probably bottom water. It's probably got a heck of a water leg in volume to it, and that's really what we need for lithium extraction. Is we need concentration, and that's never going to get very high, but we need volume. And so we want high perm, we want, extensive reservoirs and deliverability. And so we want to look at high TDS, because that's the minerals, the load that's dissolved in the brine. We also want to kind of look at some of these other kind of rare things that are worth a lot that aren't normal, which is helium, CO2, and hydrogen. And be an explorer and a leader, look outside of your kind of core group. If you're a geologist, look to engineers, look to geophysics. If you're an engineer, look to geologists, but we need all stakeholders and technical disciplines to make this work. And then propose within your company a new focus group, to the management, ESG and critical minerals extraction. They're at the forefront. And these public companies talk about it all the time, and we like to see action, not just arm waving. So where am I looking? So the Paradox Basin, and this came to me, I didn't know beans about the Paradox, so I'm working with Whiting, and we had a prospect, early on. It was brought in through equity acquisition, early 2000s, and we finally got to the point where we had to drill a well to hold a federal unit and the Hatch Point unit. And so we had 3D, and so we drilled a well, and we produced a salt brine. And that was like, okay, what do we do with that? And we thought we could put it on the road because it was a good dust control product, had a lot of magnesium and calcium in it as a chloride. And they said, well, no, you don't have the rights to that brine. And so I'm going to talk about that a little later. You have to have a mining claim to monetize this brine. You can't go off your oil and gas lease. So the Paradox was a perfect example of something you kind of stumble into, and you start looking at it. Well, it's always been a critical minerals basin since the 50s. Uranium, potassium, potash, lithium has been identified in some of these dry holes in test wells, and you had surface salt brines because you got an evaporitic Paradox formation. You got many clastic intervals. And those typically, if they have brines with them, and most of them do, will test with high concentrations of critical many minerals, mainly calcium, sodium as chlorides, magnesium, but key was the lithium. If they look for it, they're usually around that 150 to 350 part per million, which is that's pretty good. It's about what it is. The other beauty of the Paradox is it's nearly all state and federal minerals. So there's a way to amass a pretty good acreage position. And as I was saying, these high TDS brines to the point of saturation in some cases are some targets for these deep drilling. And so there's been a lot of activity recently. Solution mining for potash has been out there for many years. It's similar, except you're actually pumping a undersaturated brine or water down to dissolve out an alkalite that contains potash minerals, and then you evaporate. So you need evaporation ponds. What do we do that's different? Well, we have a small surface footprint. Nature's already concentrated the brine, the minerals in the brine for us. So all we need to do is process that out. we don't need evaporation ponds per se to concentrate it. So that's quite a bit different than what they do, for potash evaporation and also in South America for lithium production. So we looking here at the Northern Paradox below the Book Cliffs non-surface occupancy area. And we're looking south toward, or kind of southeast toward the La Salle Mountains here. In this area has had some oil and gas exploration. There's a little bit of 2D available, a little bit of 3D. And this has another salt basin. And there's remnants around that probably had something to do with the concentration in the minerals that are there. And so we started looking at some of these old well tests and mud logs, and there's a lot of overpressure here, which is good because we can actually flow wells to surface without trying to pump them. And if you try to pump a salty water well, you're going to have problems. And we found that out back in the Whiting days with our well. And so what did we find? We found a well that was drilled in 1997. It encountered a very highly pressured reservoir with a lot of volume, 11.4 pound per gallon of chloride brine. But they had to plug and abandon it. And why did they have to plug and abandon it? Because they drilled it on an oil and gas lease. Had they had a mining claim over that well site, just that well site, they could have completed that well. Now, for us to go back and twin that well with a mining claim in place, we're looking at about $9 million. So a $200 claim would have saved them $9 million or made them $9 million. So I wish they'd have, but the fact is it's still there. So are there any more of these little nuggets out there? There probably are. Anyway, it was a high pressure well. It took them 4 months and a lot of hematite mud to plug it. And like I said, it was plugged because it lacked the mining claim. But there was some water collected. We analyzed it. It was not a well publicized analysis. One of the former business partners he was on site when they drilled the well, and he had a copy of that. He chased that water sample. And it actually is something we could sell right into a current market for dust control and ice control. Kind of like what they call ice slicer mag chlorides type stuff, but it's calcium chloride, which is a little bit better. It's better for dust control. But anyway, there's only 12,000 barrels of this today in North America being sold. So it's kind of a specially liquid mineral. And so in the Paradox, if you start looking at what, the Smackover in Southern Arkansas, and that's kind of the analog that we use, realistically, the Smackover has been around quite a while. I remember days at Whiting, we actually sold some produced brine to Albemarle down there, and they were taking bromine out of it, and they were taking lithium out of it. So this was 20 years ago, 25 years ago. So that's an established basin for minerals extraction from brines. But I think the Paradox has the potential to, be an adder to that. So, what is the next Smackover? Is it the Paradox? Is it the Appalachian? Well, we'll see. So everybody knows what critical minerals. I won't spend a lot of time. This is kind of the USGS minerals list. But, the key ones here: lithium, magnesium, manganese, rubidium, yttrium, and zinc. Some of those are typically found in reservoir brines in the Paradox. So we have actual detailed analysis that show these minerals to be present. And so, but getting them out that's the trick. If it was easy, we wouldn't be talking. So here's kind of another idea of how people are getting excited, kind of in the West, a little bit, with the Silver Peak, some of this stuff. There are some brine. There's shallow wells out here that have some low concentrations, but then there's the more the load claims, and so versus a placer claim. So like Silver Peak and some of these that are, I think Albemarle is actually the owner of that one, but they have contracts for takeaway, and so these are existing mines, most of them Esmeralda County, Nevada. So here's where we're at. They were looking basically at our center stake for our well out here in just north of I-70. And I won't tell you exactly where it is, but I'm sure you can find out. But we have a placer claim. Now, do we need the oil and gas lease and the helium lease and the geothermal lease to actually mine brine on this claim? No, we do not. Probably in some cases, a good thing to have some of these other ones, just in case if you're drilling a rank wildcat out there, you want to have all your options open. So I would suggest that. This well's already been tested. There is no oil and gas. The claims, the oil and gas leases are held by others. Helium, hydrogen, probably not going to happen when you've got, heavy fluids in the well. Geothermal, potentially, we're not really hot, we're about 250 F, so you could do some low level geothermal there. The beauty of a mining claim is that a placer claim like this is it's 8/8 revenue. There's no royalty actually paid on the revenues coming from mining this claim. That's big. You have a mine plan you submit to the regulatory agencies versus the APD. So you don't have to worry about the BLM. You don't need to worry about people protesting per se. Even though you're going to put a big rig on this, it looks just like an oil and gas well to drill it, 15,000 feet. SUA is not going to be able to say, hey, what's going on here? What are you going to develop? We only need one well. We don't necessarily need a bunch of wells to make this work. So the 1872 mining law is our friend, and it's still in effect. And so that's huge. So data mining 101, what about critical minerals? Where do you find data? How do you get into, prospecting for these? Well, you got a lot of public data. The claims are at the county courthouses. You've got all your oil and gas and railroad commission files, mining commission, look at your mine operations permits, look at these big databases, the USGS studies. There's just a lot of stuff out there. Your trade publications, obviously. You've got some people looking for sources of CO2 that are out there and helium, associated hydrogen. Miningintelligence.com, that's one that most people probably aren't aware of. That's a good one. And just things like we're doing today with these technical organizations, in events and meetings and presentations, whatnot. But realistically, produced water is everywhere. So if you wanted to mine produced oil field water, you could go crazy trying to figure out, yet a high grade. And so look at Texas, Texas alone is over 50 million barrels per day of the estimated 100 million per day in America, North America alone. And so Governor Abbott, a couple of years ago, he formed this water consortium to study ways of creating economics, in revenue from in how to reuse produced water for fracking, for drinking, whatever. We're making so much of this and it's costing us to produce it and treat it. Let's create a revenue stream and let's benefit folks with that. So that's a good thing. Now here's a typical water analysis from an oil and gas producing area. And what you're going to kind of look at, what we look at is what kind of anions and cations do you have? And typical cations are going to be your calcium. Here's lithium. We want to look for lithium. In this case, milligrams per liter, ppms is about 60. So kind of low. You got some magnesium, you're about 3,800. Sodium typically is going to be high. And that's important because when you're trying to separate lithium at a small concentration out of a high concentration of sodium as a chloride and calcium and magnesium, potentially, you're going to have, it's going to be tougher. And so that's where the pilot scale processes come in. As far as anions, the key ones that you can make money on, here's your bromide. So that's a money maker on the anion side, like lithium is on the cation side. But typically your cations are going to be paired up as chlorides. That's if you're lucky. You don't want necessarily the sulfides because that means you're probably kind of sour. One thing to look at in a quick fashion is to take a look at your TDS and your specific gravity. Specific gravity is going to tell you if it's greater than 1, that means that extra, that 0.18 that's over the 1 is due to mineral load. And that's kind of what we're after, right? We're after concentration. Then we got to see, okay, what's the constituents of that mineral load? The pH, because you're as a chloride, going to typically below, be kind of a little bit slightly acidic. So here's one from North Dakota. Galen was showing, North Dakota has, this is probably some of the data that's in his little chart there that showed, the these concentration levels. But interestingly enough, lithium over here, where the arrow is non-determined. And say, what does that mean? Does it mean it's not detectable? That's what a lot of people think. But what it means is they did not run the test for lithium. Had they run the test for lithium, this would have clocked in at about 65 ppms. So not quite as high as some of it, but this is, kind of a typical North Dakota. This is kind of a Three Forks Bakken type water. So you've got a lot of volume. So if you've got some lithium with a lot of volume, that's a good thing. You see you have calcium up here, and you see you have sodium, which is very high. So this is a tough nut to crack here as far as processing out that lithium. And so again, you see your specific gravity up about 1.18. Your pH, again, 5.8, so below 7. Your chlorides are fairly high, and you don't have much sulfide. And so how do we, direct lithium extraction is kind of a big buzzword. And so that's how we get lithium out of brines without having to do evap. So we have a smaller surface footprint, right? And so the ion exchange method, and this is courtesy Goldman Sachs, they just put out a very good report on lithium, direct lithium extraction. And I found it on LinkedIn. I'm sure you guys can all find it as well. But this is just a snapshot of some of the projects that are out there. And if you look over here, kind of to the right, the lithium extraction technologies, I mean, there's various ones here. You have sorption, XI with his IX, which is ion extraction. And then some people, the TBDs are kind of like, well, this is secret. Okay. But, if you look at controlled thermal over here in the Salton Sea area, the Hell's Kitchen project, they're using, ion exchange, right? And that's a lilac process. And so each one of these, let's just say these guys are at 80 part per million. They probably don't have a lot of sodium. So in order to design a proper ion exchange, you have to know what's in it. What are the speed bumps that you're going to encounter by having certain minerals? Just because lilac's successful here doesn't mean you're going to be successful in the Smackover and or North Dakota, Utah. And so Lisbon, these guys down here are saying TBD. Well, I happen to know what that project is. And yeah, there's people that want to come out and help test, but they realize that, oh, this is a paradox. This has got a lot different, constituents than what we've already been successful for, down in California or maybe at Albemarle. And so here's kind of another slide from Goldman Sachs, and it's a little hard to read, but each one of these processes has its own advantages and disadvantages, and just working through these ideas are how, is what needs to be done. And so getting close to the end here, how do you have to do a pilot test, and then from there you're going to deploy that on site, and then you're going to scale it up and try to make it commercial. And that's kind of the end game here. And so the one that I'm working with now is the pilot test system. Going to deploy it on site, and we're going to process approximately 65 barrels a day. That's oil field barrels of source brine, which has a mixed contamination with, you've got, I call it contaminants because we're not looking for those. So you got sodium, magnesium, calcium, potassium, and iron. And I want to get an output concentrate of approximately, from that 65 barrel day, 2 kilograms of lithium per day, with less than 1% trace metal contaminants. So that's a pretty tall order. From what little I know about it, this is something that a lot of the the mineral processing guys, they're all working hard on it, because whoever can break this this barrier, and like I say, each one of these brines is going to be different. So it's never going to be, aha, I got the secret sauce. So everyone's got to do their work. And once the pilot testing is completed and successful, you go out there and you contact and engage these leaders in the US, these mining companies, these Albemarles, and the people that are wanting to, sell battery minerals, to Ford and these folks. Let's go ahead and and get your brine composition and your volume, and let's figure out, what it's going to cost. What do the economics look like? And so we'll kind of end with that. This is kind of this is actually at Michigan, and this is solution over time of a limestone formation on Lake Superior. And again, mine to brine. So I guess we'll open it up to questions. Just one more little throw in here, since it's been a long time since Denver's been in the finals. In fact, this is the first time. Here's a miner leaping for joy. And maybe that's a lithium coated basketball at some point.
That's great. I love it. So wonderful. This is really amazing. And just want to say that really appreciate all the enthusiasm in the audience. Why don't we go through the questions that have to do with the Smackover and Galen's presentation first? Galen, have you had a chance to take a look at the questions in the Q&A?
Yeah, I've taken a look. I've been looking through some of them here.
You want to jump in? And
just kind of go down the line here. 1 second.
Perfect.
First one in the convert. No, that's not a question. And Thomas kind of went over this first question that was here. Was the current process to separate the solid lithium from the brine? So the resource numbers I calculated, that was just, whole rock, what's their total possible down there in a hypothetical situation in the Smackover. That's not including, stuff you might lose in the extraction process. That's not going to include the dilution over time as you're re-injecting water back down in. That's just that's sort of like your oil in place map. What's the lithium in place? In the hypothetical situation I brought up.
One thing I've noticed that there's quite a bit of confusion about lithium, evaporites, halite, source of Luan, source being the Luan, source being volcanics. And I think that you might talk about the process of it, because they're not mutually exclusive.
Right. So again, there's multiple possible sources bringing lithium into the system. First is just the seawater. Seawater naturally has about 20 to 25 parts per million lithium in it. So there's going to be some there to begin with.
Say, Galen, that is not correct.
No?
No.
Okay.
We're talking about billion parts per billion, and not, seawater has a very low concentration.
Okay.
That's a very wrong concept.
Good. Great.
And I wrote a question long ago and I don't see it. Maybe something went wrong. This is Swapan, by the way. And I actually open question to you and Tom. Nice presentations, but you guys follow Smackover. Mm-hmm. But do we actually understand Smackover?
Yes, there are some understanding. Yes.
Like what is that understanding? It will be nice to know, really.
Okay, but let's be polite and go through the people who've written and follow the protocol, not just LinkedIn. So I appreciate your question, but let's don't just. So anyway, go ahead, Dan.
Yeah. So, in just response to that, so there is a lot of literature on the Smackover. People have been producing from the Smackover for over 50 years. So just for oil and gas purposes. So I might not be the expert on this Smackover. There's likely other people on this chat that have worked the Smackover for large portions of their career that know it possibly better than I do, but there is a lot of known about the Smackover.
This is Mason. I worked on the Smackover Formation in Oklahoma as a reservoir engineer. So it's well-developed geology information there. So I don't want to drag everybody offline. So I just say it is well studied.
Yeah, thank you, but let's, we have a lot of people who politely put their questions in the Q&A. And so we won't be able to get to them if we just keep jumping in with them. And we've got a lot of people.
Right.
So let's just follow the protocol. And I'm going to put a few things in the chat if you want to get, but go ahead and continue.
So yeah, in response to, so Leslie Miller asked, you know, there was a region in the Appalachian that appears to have high concentrations of lithium. I haven't personally looked at that area. I haven't just taken the time to get into the ins and outs of the Appalachian. So, you know, my focus has been on the Smackover because I worked it, you know, with XTO, and then I came across Standard Lithium, who was also in it. So that's just been my area of focus for the last couple of years. So it very well could be deposits, brine deposits to be had in the Appalachians.
Can I make a comment quickly here? Yeah.
Does it relate to that question?
Yes. Yes.
Okay.
So be aware that the lithium concentration, the source for that is not necessarily a salar. So particularly in the Appalachians, you know, we are talking about other sources, like in Nevada, you know, where they have volcanic rocks, which are actually providing the lithium. Thacker Pass, for instance, where they mine lake deposits, which are high lithium clay concentration and so forth. So the Appalachians is a different, let's put it as a different play than the Smackover play.
Sure, for sure. Yeah. And even within the Smackover itself, I suspect, you know, there could be multiple sources depending on whether you're in East Texas, South Texas, Florida, you know, Alabama. Just because one place has a source doesn't mean it's the same even all the way across the Smackover.
Right, and just to clarify, if you look back to your diagram, you might go back to the depositional diagram. So find that the Smackover is Jurassic. The Luan salt underlies it, so that's earlier, but keep in mind that this is a time of lots of volcanic activity. So you have volcanic ash, and much of the source of the lithium, and that could be in the lithium in the seawater or whatever, it originally came from the elemental lithium, as has been in this diagram. Actually, it often happens as a result of weathering of volcanic ash. And so it's a hydrothermal process. So then if you have concentrations in hydrothermal, you can have pegmatites. So pegmatites would be concentration of lithium in a different system, but you have that hydrothermal system. So that leads to the rapid degradation of lithium. So Herman, is that pretty much what you're saying?
Sorry, I had to. No, you are totally right. You kept it correctly. The ultimate source for the lithium is actually the volatile part of the crystalline sequence, so pegmatites. Yeah.
Right.
And
yeah, that's going to be the source, the original source for just about all of it. It's just what's the path it's taken to get where it is now in its concentrated form. You know, is it just the pegmatite itself, like a lot of the Australian deposits, or has it been put into clays, like you said, in Thacker Pass, or salars like Nevada, or the Alta Plains in South America? You know, there's lots of different flow paths, and I imagine, you know, the early Luan deposits being similar to, in ways to like a salar deposit, the modern salar deposits, where you had opening, you had rifting of the Gulf of Mexico, you had shallow, really shallow waters coming in, evaporate evaporites forming, concentrating the lithium brines along with the bromine or other minerals. So
You're right. Restricted basins is the key word here.
yeah.
Absolutely.
Good
Do
point.
you have any analysis from the Norphlet sands between just on top of the Luan, because they have some good permeability and some high flow rates and are overpressured at times?
Right. I haven't seen water samples from the Norphlet with lithium concentrations. It wasn't drilled as much of the Smackover, you know,
No.
since it is quite a bit deeper. So I think there's just less known about it, not as many samples taken. You know, most people weren't looking for lithium when they were doing their chemical analysis of their oil, you know, or even the water itself. So it very well could be, you know, and it's just this, there's more information on the Smackover.
Thank you.
Swapman, sorry, I didn't, you're right, you did put your question in, I just didn't see it, we didn't see it. So just to clarify, and I think this is one area of confusion, somehow the mistaken idea was that lithium comes from halite. Halite, and it's not, it's intercalated into, well, anyways, evaporites. Somebody might clarify, because somehow there's some confusion.
Can I say something?
Sure.
So I think, I mean, the reason I'm just bringing this up is because, like you said, Susan, it's a lot of confusion, and rather than saying halite, it sounds fascinating. Oh, the Luan salt. Ask realistically, does table salt halite have lithium? No. Does anhydrite have lithium? No. Potash might have lithium, but where is the potash? Can we map it out? So you have to think it that, oh, my Smackover is sitting exactly on top of where the potash was depositing. But the Luan salt has moved all the way to the deep water Gulf of Mexico. So you know, these are the questions that it's very easy to just arm wave and say like, oh, I have a salt basin, so I have lithium. But then you guys are saying the volcanism is the ultimate source. That cannot be right either. Go to Bakken. There is no volcanism. It's an intracratonic basin with absolutely no volcanism.
Well, you're talking about igneous intrusions. So it may not
There is, in Bakken, there is no intrusion either.
Oh.
So there are large evaporite deposits below the Bakken. It's not the Bakken itself that has.
I have tested hundreds of samples of prairie salt. Tell me, where is the lithium?
Of what salt?
Prairie salt.
Prairies.
That's the, you know, late Silurian prairie salt, which is like you know, 1,000 to 2,000 feet below the Bakken.
Mm-hmm.
The potash, you will be surprised. I'm not giving you secrets, but the potash has no lithium. So where does the lithium come from?
So let's back up a bit. So one of the big areas of, and I'm not an expert in this, I'm just talking about things that I
Me either. So I'm just having fun.
heard. So a lot of the lithium and a lot of the black shales have high concentration of critical minerals. And so there's been some work done in Arkansas on that. And also in, Randy Blood has done work in that in Appalachia. So the shales contain that clay mineralogists have studied that. So I think that instead of trying to tease out, we might like use this opportunity to like dig into, do a literature review of the clay mineralogy of these areas to see where there are high concentrations of lithium in the black shales.
I agree with that. To be honest, although lithium is believed to be like a weathering proxy, like a detrital flux, and you know, like trace metals like say moly, vanadium, they are more with redox. Lithium, it should not be with redox, but apparently in many of these cratonic basins, particularly the Laurentia, Devonian cratonic basins, we do see a lot of lithium in the black shale. So I definitely agree with you on that for sure. This is more realistic than, you know, a Luan salt or a salt. Salt actually can help to maintain a brine levels in the basin. But it may not be necessarily the source of lithium in the basin. That's just my thought and what I have seen, for the last few years. But it's a tricky thing, and nobody really knows the answer.
Can I make another comment here, please? We talked about the source of lithium. I do not want to give away my exploration secrets of our little company here, but you have to understand the migration pathway of your fluids. And that is basically, we do not need a trap. That's a good thing today, because we need just a water leg or a fluid. But you have to understand the migration pathway between the source and your reservoir at the end of the day. That's the key. I do not want to tell them more.
Right.
That's a really good point, Herman. I'm really glad you brought up the concept of the migration pathways. So just in the interest of time, because we're over time, we have so many participants, we haven't gotten to all the questions. I'm going to ask people to just hold up. I don't want to have to actually mute everybody, but I will, because I want to make, if I have to, because I really want everybody to have a chance to, I want Galen, and especially Tom, to have a chance to talk about the process of extracting, converting the different stages of lithium and getting, I mean, I know it's a proprietary process, but talk about that a bit.
So,
Tom, go ahead.
Thomas,
Okay, so yeah, I'll just say, I have answered some of these Q&As out there that reference me. So that helped while you guys were talking. So realistically, all these processes, they're key, and that's why they're proprietary. No one's going to give out their process, willy-nilly to somebody that says, well, here's my water sample. You see, if it looks good, like if you say I've got 300 part per million and I've got 20,000 barrels a day and I got a resource estimate of 4 million barrels in the ground. Now we can start putting some brackets around what the value is, because we can run the numbers and say, okay, this is the ultimate recovery here. At this concentration equals this many metric tons of lithium potential. Okay, so we do our mine feasibility thing, and that's different than oil and gas mentality. It's not like signing reserves, so it's a little bit different, but people do it all the time. And then you get attraction from these people that have a specific process that say, I think I'm going to try to crack that nut. I think I've got mine is pretty close here in Nevada to what you got in Utah. I think it's an easy one. I want to go in and test. So they'll come in and actually test your brine and do some lab work, and then maybe do a little pilot like they did in the Smackover with Albemarle and what Galen was talking about. And then you can make the big press release. Now we're kind of we go live, now we can get monies in, and yet you can deliver, you can have offtake. And that's what's key, because oil and gas has always had a crutch, which is NYMEX. There's always going to be someone to give you a certain price for your oil. Mining world is much different, and that's what a lot of people can't wrap their head around. You got to make your own market. You've got to understand the market, and you can't pollute the market. You can't overproduce. And so it's really been an interesting 5 years in just understanding the hurdles that oil and gas people don't care about. They just got to find it. Someone's going to take it, and it's easy to process. It's well understood. It's easy to refine. We're having to do this all over again, reinvent this whole thing now to take lithium out of brine. And so it's not going to be easy, but it's happening. And I'm just to say that, we all got to kind of work together. I mean, no one's going to steal anybody's claim because they have a process. I mean, there's plenty of claims to be had, and there's plenty of volumes that are operated by majors up in North Dakota that I'm working with some of them. That if you can crack the nut on a certain formation's brine that has maybe 60, 70 part per million lithium, that's pretty much a cookie cutter for the rest of the Bakken, right? So those are the kind of targets I'm looking at. Let's find something that's scalable, that actually, if you can solve it on one guy's lease in North Dakota, it's going to work for everybody.
And thank you. And just another thought about the process. So the process that's being used in the Smackover is called direct lithium extraction. And that's supposed to speed up the process over the evaporation ponds, et cetera, that are being used, that are used in Chile and Bolivia and the salars, which it can take up to 18 months. But what they've talked a lot about, oh, thank you. So yes, so perfect. So let's, so Tom, go ahead and talk about this.
Okay, so you look at the variations between salars means there's unlikely one size fits all solution, although solutions may still offer some transferability. And this is from the Goldman Sachs. So I invite everybody to Google that and get it. But these different extractions, you got precipitation / evap. So that's, you pump it to surface into the evap ponds, and it takes a long time to get it concentrated down. It's cheap, but it has a big footprint in environment. They're going to protest it. Solvent extraction is another one that's, it has an organic solvent in the extraction. So you've got some chemical issues. It's fairly high cost. There's adsorption where, it's efficient. It's a simple process. You have to have a sorbent media, but it has additional process. Every one of these has a plus and a minus, is kind of my point. And you're gonna have to tailor each type of DLE process to what your specific constituents. The one that's really the ion exchange to me is the best, because if I have a valuable brine that I can sell into an ice control market or a dust control market, and I only have 200 part per million lithium in that, I don't want to destroy my brine that I can sell and make money on it, say $50 a barrel, just to get out a little bit of lithium, right? I want to be able to do both. I want an additive revenue stream. So I want to be able to take out with that ion exchange, grab those lithium ions, and then sell the resultant effluent into my dust control and ice control market. See how, so you have to look at what you have as a resource in that brine and make sure you're maximizing the profitability of it. The membrane separations just based on the size of the molecules. So that's another one that's going to depend on what, your fouling. You get a lot of fouling if you have a bunch of sodium. You have to get that sodium out of there first, and that's expensive. And everybody, salt's everywhere. So it's really a complex item.
Quick question on how much fresh water you are planning for your ion exchange to use?
Ion exchange doesn't take a lot of fresh water, and you can kind of look at some of these that need a lot of fresh water. In some areas, that's a big concern. Obviously, water's precious, especially drinking scale. I mean, when they say fresh water, it's typically not something you would be drinking. Let's put it that way. I mean, it's not drinkable water, potable water. It's just a non-brine water, something less concentrated than what you're trying to use here or extract from here.
Okay, so we don't really have time for any more of the comments. When we have smaller meetings, we usually have a chance for people to open up their mics and chat a bit, but we're way over time, and I wish this is such a great topic. I wish we had hours, and we could. So I encourage everybody to read the chat, great comments in there, and also to read the Q&A and the answers there. And I just want to comment that if you need professional development hours, when you receive your email with the link to the recording, I will also put a link where you can register and get 1.5 professional development hours. And there's a slight processing charge. And those are APG professional development hours. So I want to say thank you to everyone. This has been great. Really appreciate it. Lots of enthusiasm, and we should probably do another one where we focus even more on the Smackover itself, or the process of the lithium concentration. I think there's definitely there's a wealth of information and lots of work being done on that. So thank you, everyone. I'm going to stop recording, and I'll be in touch.